Okay, in this video I'm going to talk about the energy associated with the formation of chemical bonds in a very general sense. Chemical bonds form basically because there are regions where atoms can exist close to each other where the electrons of one atom can see the positive nucleus of the other atom, and there's an attraction there. So if we imagine we have a positive nucleus and we have an electron, and we have a secondary atom, and we have a positive nucleus and we have an electron, these guys, the plus and the minus, can see each other more than these guys. So this attraction, there can be more attraction between these unlike particles than there is repulsion. So we can get into an energetically favorable situation, or we can get into a stable, attractive situation as long as the distance between these two atoms, and if we consider this the distance between the two atoms, the distance between their centers, d, is right. So if we think this through, we're going to go through energy, and we're going to go through in three basic regions. So first of all, in general, we're going to be talking about energy versus atomic separation distance. So this is the distance between the atoms that are forming the bond. And this is the energy associated with that bond. Keeping in mind that repulsion makes unstable energy situations and that is associated with a positive energy, which means the atoms don't really want to stay here. Do not want to stay here. Alternatively, negative energy is associated with attraction. That's stable. The atoms want to stay together. This is considered a negative energy situation. I think from a chemical bond perspective, this is a little hard to wrap your head around, but if we just pause here for 1 second and we go over and we imagine a hill and a hole and a ball. So here's the level ground, here's a ball, here's a hill, and here's a hole, and here's a ball. Here, we would say the ball has positive energy. It's above its usual energy state. We'll call this zero energy right here. What that means is the ball has energy that it's able to transfer to motion. Here we can see that positive energy is an unstable state that wants to be changed into some other type of energy, motion, heat, whatever it is. Alternatively, a ball resting on this flat part right here has zero energy. It doesn't want to go up, it doesn't want to go down, it's just going to sit right there. Finally, a ball that's stuck in this hole, or a ball that has negative energy, is in a very stable state. Unless something comes along, this ball's going to stay right here. You would have to put energy in just to get back to zero. We could do that, say, by throwing the ball with motion or whatever. So again, positive energies are associated with balls being in states where they're ready to move, or they have energy that's available to be transferred into other forms. So that's an unstable situation. Unstable. I'll just try that again. Unstable. Zero energy is normal, and negative energy is when we're actually like in a hole, we're in a very stable situation, we'd have to add energy to get out of this situation. Okay. So with that in mind, we get the idea that repulsion is the positive energy situation and attraction is the negative energy situation. So let's go through these two things. When the atoms are very far apart, there's going to be no interaction at all. So that's out here. So we got to go to 0 here. When the atoms get close, there's an attraction between the electrons of one atom and the protons of the nucleus of the other atom. And so this dips. It dips and dips and dips, and it hits sort of what I'm going to call a perfect spot right here. This would be the bond length, or how far apart these atoms like to sit. Here, the electrons from one atom are attracting or attracted to, it doesn't matter, the nucleus of the other atom. Here, the nuclei don't see each other that much. Now, if these two atoms then try to get too close together, they're going to repel. And when they repel, any attraction that was there is going to get lost. And we can see this is going to almost go off asymptotically. And this positive energy is associated with the repulsion of the two positive nuclei. Positive nuclei. So we have three basic regions. Far apart is where we consider to be zero energy, and that's associated with basically no interaction between these two molecules. As they come closer together, there's a brief region where the attraction between the electrons of one and the protons of the other can lead to an energetically stable or negative energy situation. And then finally, when they get too close, there's a repulsion of the two nuclei, and they're going to have to fall apart. In general, what this means then is that when atoms start far apart, way out here, and they come together, most atoms move to a lower state of energy when they're doing that. And when they do that, just like a ball rolling down a hill has energy that was potential energy that's now available for motion, the atoms that moved from this high energy state to this low energy state have potential energy, and it's now available for motion. But because we're talking about atoms, we don't typically see that as motion. We see it as changes in temperature. Or heat. So that's the energy in the formation of a chemical bond. When they're far apart, there's a little attraction. When they get close together, we get this negative stable energy situation where we have an attraction between electrons and protons. If they get too close together, we get this huge repulsion, and they can't do it. Since most of the time they'll be moving from zero to a negative energy state, that means they're moving to a lower energy state. That energy that they've decreased, if they went from 0, say, to -5, that -5 that's now available can be used by the environment to make heat or to make it a little warmer. So most bond formation then is what we call exothermic, or energy is being released, from atoms to the environment.